In this video, I will teach you how to find the area of a polygon using matrices. Now, in a previous video, I showed you how to find the area of a triangle using matrices. So, in this video, we're just going to split the polygon into triangles and add them up. Now, you can use a similar technique to find the area of any polygon. Let's start by plotting these vertices. Okay, here I've plotted all the points. Now let's go ahead and draw the polygon. Alright, so here's the polygon with the vertices given. Now the way that we can find the area is by separating this polygon into triangles. Alright, the strategy that we've used so far relies on finding the area of triangles. So if we can divide this into triangles, we can just find the area of each triangle. So if I make a diagonal from vertex to vertex, alright, so I've formed a triangle there, and I'm just going to do that one more time again from vertex to vertex. Now I could have gone from this vertex to the other vertex, and it would have been the same area. So I've separated the polygon into three triangles, and I will refer to these triangles as triangle A, triangle B, and triangle C. So I'm just going to use the technique that I used on the previous problem to find the area of each one of these triangles. Okay, so let's start with triangle A. Alright, so triangle A will give me matrix A. So starting with the vertex 1, 3, I'm going to have 1, 3, and then 2, 9, and then 10, 11. Okay, those are my vertices. Of course, the third column is going to be 1, 1, 1. So that's triangle B. Sorry, that's triangle A. Now here's vertex B representing triangle B. So I will start with this vertex 1, 3, so that's 1, 3. And then the next vertex is 10, 11. And the last vertex is 6, 2. So these are the vertices of triangle B. And again, the third column will be 1, 1, 1. Okay, now let's move on to the final matrix representing the final triangle. So this will be matrix C representing triangle C. Okay, so the vertices are 6, 2, 10, 11, and 13, 7. And one more time, the final column will be 1, 1, 1. So I need to find the determinant of each one of these matrices. All right, starting with the determinant of matrix A. For matrix A, I'm going to choose the top row for my cofactors. So my first cofactor is 1. So that means my minor determinant, my first minor is going to be 9, 1, 11, 1. So 9, 1, 11, 1. Okay? For the first row, the sign pattern is positive, negative, positive, meaning keep it the same, change it, keep it the same. So my first cofactor, I will keep the same sign. But my next cofactor, which is positive 3, according to this, I need to change it. So I'm going to actually do a cofactor of negative 3. Okay, now let's talk about the minor determinant that goes with that. If I could just erase this yellow up too much. Okay, so the minor determinant is going to be 2, 1, 10, 1. And now the third and final cofactor is 1. Okay, according to the sign pattern, I keep this cofactor the same sign, and my minor determinant is 2, 9, 10, 11. Okay, so I just need to do these calculations. So the determinant of matrix A, multiplying by 1 isn't going to change anything, so I'm just going to have the down diagonal minus the up diagonal. So that'll be 9 minus 11. And then minus 3 times down diagonal minus up diagonal. So 2 minus 10. And then plus, multiplying by 1 will change nothing. Down diagonal is 22 minus the up diagonal, which is 90. All right, I did the rest of those calculations off camera, but I'm sure you can follow through and see that the determinant of A is negative 46. Now I'm going to do the same thing for matrix B. So I choose row 1 for my cofactors because I like the fact that it has 2 1s in it. So here I go for the determinant of matrix B. All right, so my first cofactor is 1. So my minor, for my minor, I'm going to go ahead and cancel out that column. So that leaves me with 11, 1, 2, 1 for my minor. And according to the sign pattern, which remember goes positive, negative, positive, meaning keep it, change it, keep it. I keep the sign the same on that one. But now when I move on to my second cofactor, which will be 3, so I'll be canceling out this column. But instead of putting 3, I'm going to put minus 3. All right, I have to change that one. And then my minor determinant will be 10, 1, 6, 1. And then my final cofactor is the number 1. Crossing out that column is going to give me plus 1 times the minor 10, 11, 6, 2. Okay, so the determinant of B, the 1's not going to do anything, but down diagonal minus up diagonal, down diagonal minus up diagonal. All right, the 1's not doing anything, so down diagonal is 20 minus the up diagonal, which is 66. All right, I will calculate the rest of this off camera. Okay, so here are the rest of the calculations, and I found that the determinant of matrix B is negative 49. Let's do that one more time for matrix C. So now we just need to calculate the determinant of matrix C. So let's get started. So the determinant of matrix C, well, we have to choose which row we're going to do. And you know what? I think I'm going to use row 1 once again. It has the smallest numbers in it, so I'm going to go ahead and use row 1. So that means my first cofactor is going to be the 6. So I'm going to have 6, and then the minor matrix 11, 1, 7, 1. Okay, and then I'm going to switch over to the next cofactor, which is the 2. Canceling out that column, well, first of all, the 2. Remember the sign pattern for the top row is positive, negative, positive. Means in terms of the cofactors, keep it, change it, keep it. So the middle one, I need to change the sign. So I'm actually going to put negative 2 times the minor determinant, which is 10, 1, 13, 1. So 10, 1, 13, 1. And then it's time for the third cofactor and minor. So the third cofactor is 1, which leaves the minor determinant 10, 11, 13, 7. All right, so I just need to evaluate these. Okay, so the determinant of matrix C is going to be 6 times down diagonal minus up diagonal, so that'll be 11 minus 7, and then negative 2 times down diagonal minus up diagonal, and then the 1's not doing anything, so I'll just have down diagonal, which is 70, minus the up diagonal, which is 143. I'm going to do the rest of these calculations off camera. So I'm sure you can follow your way down through these calculations, and the bottom line is I got the determinant of matrix C is equal to negative 143. Not negative 143, negative 43. So let us review. The determinant of matrix A was negative 46. The determinant of matrix B was negative 49. And the determinant of matrix C is negative 43. So I'm going to take those three numbers, and I'm going to take half of each of them. Notice that I'm not putting negative, though. Area has to be a positive number. So instead of putting negative 46 or negative 49 or negative 43, I just put positive numbers, all positives. If I take half of each of them, that'll be the area of each one of these triangles that we formed. All right? As soon as I take half, that gives me the area of triangle A, the area of B, and the area of C. So of course, if I add up all three areas, that'll be the area of the polygon. So you can follow through here where I've taken half of each quantity, and the sum is 69. So the area of the polygon is 69. Let's do one more example. These are the vertices of a polygon, and I would like you to find the area of the polygon. So I encourage you to pause the video and try to do this problem by yourself. So I'm assuming that you've done that. So our first step is to plot these points. So here I've plotted all the points. So now let's just connect the vertices to form the polygon. So now I'm going to pick a single vertex, and I'm going to start drawing diagonals to divide the polygon into triangles. Okay, so here I've divided the polygon up into triangles. I will call this triangle A, and triangle B, and triangle C, and triangle D. Each one of these triangles will correspond to a matrix, and I'll just I'll do one of them here, and then I'll do the rest of them off camera. But so for example, looking at triangle A, I have the 3 vertices, starting with -7, -6. So I could make a matrix by putting -7, -6, and then -10, 2, and then -9, 8. All right, those are the 3 vertices of triangle A. I need to make a third column that just has the number 1 in it. 1, 1, 1. So because I took this matrix from triangle A, I will call this matrix A. So I'm going to do the same thing 3 more times and make a matrix for triangle B, triangle C, and triangle D. And I'll just do that off camera. All right, so here, in addition to matrix A, I have now formed matrix B, and matrix C, and matrix D, using the vertices of the other 3 triangles B, C, and D. Now, my next move is to find the determinant of each one of these matrices. So I will set up the determinant for matrix A in detail, and then I will set up the determinants for the other matrices off camera. So let's start with matrix A. I have to decide which row I'm going to use. All right, so I want to find the determinant of matrix A. I'm going to pick the row that has the smallest numbers in it. So I think I'll just use row 1. Okay, so I'm going to use row 1. This is the row that will give me my cofactors. These are the numbers that will go in the front of each minor determinant. So my first cofactor is -7. So I'm going to put, whoops, that was a highlighter. So I'm going to put -7, and then I'm going to form the minor matrix by canceling out not only the row that contains the -7, but also the column that contains the -7. All right, that leaves the minor determinant 2, 1, 8, 1. So I will put 2, 1, 8, 1. So that's my cofactor and the minor. Now I move on to the next cofactor, which is the -6. So that means I need to cancel out that particular row. Now, the middle cofactor, I need to change the sign. So I'm going to put +6. And then I will put the minor determinant. So this will be -10 and 1 and -9 and 1. Okay? And by the way, the sign pattern goes like this. For the first row, if I use the first row, I go plus, minus, plus. That means in terms of the signs, I keep the first one the same, I change the middle one, and I keep the third one the same. If I were to do the middle row, it would be change, keep, change. And if I do the bottom row, it would be keep, change, keep. All right, so just memorize that little pattern. Anyway, back to the determinant. So I'm going to move on to my last cofactor of 1, which means I need to cancel out this column. So I have this cofactor of 1, and I will keep the sign the same. So I will do +1, and then I will have the minor determinant, -10, 2, and negative 9, 8. All right, so I just need to do these calculations. So the determinant of A is going to be negative 7 times the down diagonal minus the up diagonal. So 2 minus 8. And then 6 times the down diagonal minus the up diagonal. So that would be negative 10 plus 9. The up diagonal is negative 9. Minus negative is a positive. All right, now this 1 is not really doing anything, so I won't put it. But down diagonal minus up diagonal. So negative 80 plus 18. Again, negative 9 times 2 is negative 18. I put plus because minus a negative is a positive. All right, now I'm going to do these calculations off camera and trust that if you're working at this level, you can do this simple order of operations. So the determinant of A is negative 26. Now, I'm going to go on right now and start building the expression for my area. So the area, as I find these determinants one by one, I'm going to take half of them and I'm going to make sure that they are positive because area is always positive. So I just found that the determinant of A is negative 26. So I'm going to put 1/2 of 26. Now I'm going to keep going and find the determinant of matrix B, matrix C, matrix D, and every time I find one, I will add it on to this area expression. All right, so let's move on to matrix B. So now I need to find the determinant of matrix B. So the determinant of matrix B, I think I'll just stick to the first row again. So that means I will do negative 7 as my cofactor times the minor, which I will get by canceling out the column as well. So that leaves me with a minor negative 8, 1, 10, and 1. Okay, now let's see if can I erase this without erasing more. Okay, my next cofactor is negative 6. But I need to change the sign, so I'm going to do plus 6 for this middle one. And that leaves the minor determinant, negative 9, 1, negative 5, and 1. Okay, next I move on to the final cofactor of 1. So I will cancel out that column. So I don't change the sign for this one. So I do plus 1, there's my cofactor, and now the minor is negative 9, negative 8, and negative 5 and 10. So I just need to calculate this out. So this is going to be negative 7 times down diagonal minus up diagonal. So negative 8 minus 10. And then I'm going to get plus 6 times down diagonal minus up diagonal. Now I put plus because the up diagonal is negative 5. Minus negative 5 is plus 5. Down diagonal is negative 90. The up diagonal is 40, so minus 40. So I'm going to do these calculations off camera and trust that you're able to do it yourself. And I'll be right back with the determinant of B. So the determinant of B is negative 28. So I'm going to add that to my area expression. by doing half. Now, I got negative 28, so I'm going to put positive 28. You always put positive because area is always positive. All right, now I'm going to move on to matrix C. And once again, I will just use the top row for my cofactors. Okay, so I am calculating the determinant of matrix C. And I will have my first cofactor is negative 7, and the minor is going to be, all right, if I cancel out the row that has the negative 7, it reveals negative 10, 1, 6, 1. So negative 10, 1, 6, 1. That's the minor. Now, next cofactor. The next cofactor is negative 6. Now, in the middle of the top row, I need to change the sign. So I'm going to put plus 6. And then the minor determinant, negative 5, 1, 8, 1. All right, and then I move on to the third cofactor. All right, the third cofactor is 1. And I don't change the sign, so I will just put plus 1 times the minor determinant, which is negative 5, negative 10, 8, and 6. Now I just start calculating this thing out. This first determinant is just down diagonal minus up diagonal, so this is negative 10 minus 6. And then again, down diagonal minus up diagonal, so negative 5 minus 8. All right, here the down diagonal is negative 30. And the up diagonal is negative 80, so I need to do plus 80 because minus and negative is positive. Now I'm going to do the rest of this calculation off camera. I know that you could do it. I'm getting that the determinant of matrix C is 84. Okay, and so as I add that to my area expression, I'm going to put plus 1/2 of 84. Now notice how much bigger this number is compared to the other two, and that makes sense because look at how big this triangle is compared to triangle B and triangle A. So at a glance, I would expect the determinant of matrix D to be smaller in absolute value, smaller than matrix C, but yet bigger than A or B. Let's see if that's true. I am now about to calculate the determinant of matrix D. Now, I think I'm going to use the middle row this time, mostly just to shake things up. I've used the first row on almost every problem. So just be careful of one thing. The sign pattern, I don't mean to use a highlighter. The sign pattern for the middle row is going to be negative, positive, negative. When I use these three numbers as cofactors, this negative means change the sign. The positive means keep the sign the same. And this negative means change the sign. So I'm going to change it, keep it, change it. If I were to use the top row, it would be keep, change, keep. And it would be the same on the bottom row. If I were to use the bottom row, it would be keep, change, keep. So make sure you have this pattern memorized. But we're using the middle pattern right now. Okay, so starting with the cofactor of 8. Okay, so I'm going to start by putting the cofactor of 8. But as I just said, I need to do negative 8. I need to change the sign. So I'm going to go ahead and put a negative 8. And then the minor determinant. The minor determinant is going to be what you get if you cross out not only the row but the column of the cofactor. So that's going to leave the minor determinant of -6 and 1 and 2 and 1. All right, now I move on to the next column. All right, the column that has the 6 in it. So I'm going to cross out this column. So now I'm using a cofactor of 6. And this time I'm supposed to keep the sign the same. So I'm going to have a +6 in front of the minor determinant, which will be -7, 1, 13, 1. And then I will move on to the last cofactor of 1. If I cancel out this column, it reveals the minor matrix that goes like this. So remember, see this minus sign? I need to change the sign though. So I'm going to put -1 in front of my minor. -7, -6, 13, 2. Okay, now I just need to calculate this all out. So I'm going to do my -8, and then this determinant is down diagonal minus up diagonal. So -6 minus 2. And then I'll have my +6, and then down diagonal minus up diagonal. So -7 minus 13. And then I'll have my -1, down diagonal minus up diagonal. So this will be -14 plus 78. 13 times -6 is -78. Minus a -78 is positive. That's why I'm adding. All right, so I will finish the rest of these calculations off camera. All right, so I'm getting a determinant of matrix D equals -120. That's bigger than I was expecting. That's pretty weird. But it must be an optical illusion. So I'm going to go ahead and put +1/2 of 120. All right, even though it's -120, I always put positive because area has to be positive. Let me just erase these pluses and minuses for a second. So that's it. This is my expression for the area. All I need to do is calculate this out, and that'll be the area of the polygon. So you can see here I've taken half of each one of these numbers, and I got these, and I added up those numbers, so the area is 129.
Pardon me, are you Aaron Burr, sir? That depends. Who's asking? Oh, sure, sir. I'm Alexander Hamilton. I'm at your service, sir. I have been looking for you. I'm getting nervous. Sir, I heard your name at Princeton. I was seeking an accelerated course of study. When I got sort of out of sorts with a buddy of yours, I may have punched him. It's a blur. Sir, he handles the financials. He punched the birds.